Okay, now we're on part 2, moving on to the last example. So what is the tension in each wire? By each wire, I'm saying, let's call this X, and let's call this Y. So if you know this is 100 pounds, and you know that's 30 degrees, and this is 60 degrees, I want you to find the tension in each wire. Another way of saying that is find the magnitude of X and the magnitude of Y. Pause the video, find the tension, unpause when you're ready to check your work. Okay, so we should end up with the magnitude of X is 50 root 3 newtons. You could also type that into your calculator around to 3 decimal places. I didn't specify here if I wanted exact answers or not. And the magnitude of Y is 50 newtons. And in fact, going back to the exact answers versus decimals, decimals actually kind of make more sense in this case. I just didn't type it into my calculator. Okay, how do we come up with that? So, back up here. So if this is X, then the X vector is going to be the magnitude of X times negative cosine of 60I minus sine of 60J. Sorry, I just realized I completely switched my X's and Y's. So to correct that, I'm going to do this, and we'll call this Y, and call this X. I apologize for that. All the work was correct. I flipped which ones I had labeled. So again, this is X. So the vector X is going to be the magnitude of X times negative cosine 60I minus sine of 60J. Why are these negative, you might ask? That's because this 60-degree angle would be in the third quadrant because of the orientation of the angle. That's very important to the problem. For Y, this 30-degree angle would be in the fourth quadrant because of the orientation of the angle. So this is going to be the magnitude of Y times the cosine of 30I minus the sine of 30J. Okay, and then I know the resultant of these two vectors. If I add them together, I get this 100 pounds going down. So I know X plus Y is negative 100J. So now I need to write a system of equations. So the I component of this resultant vector is negative magnitude of X cosine of 60 plus magnitude of Y cosine of 30 equals 0, because the I component of this vector is 0. The J component is negative magnitude X sine of 60 plus magnitude Y sine of 30 is negative 100. Now I have a system of equations. So first I rewrite this. Cosine of 60 is 1/2. It's negative because of that negative. Cosine of 30 is root 3 over 2. Sine of 60 is root 3 over 2. It's negative because of this negative. Sine of 30 is 1/2. It's negative because of the negative. So now I did elimination. So I multiplied the top equation by 1/2. I multiplied the bottom equation by root 3 over 2. So now I end up with negative 1/4 magnitude of X plus root 3 over 4 magnitude of Y equals 0. Negative 3/4 magnitude of X minus root 3 over 4 magnitude of Y equals negative 50 root 3. Add the equations together and the magnitude of Y's go away. And so I'm left with negative magnitude X equals negative 50 root 3. Therefore the magnitude of X is 50 root 3. Now to find the magnitude of Y, I went back to this equation right here, and I plugged in the magnitude of X. So that's where I got the 1/2, the negative, and then the 50 root 3, plus root 3 over 2, magnitude of Y equals 0. Solve that for the magnitude of Y, and you end up with 50 newtons. Okay, so we want to make sure we understand theta is the direction angle. If V is any vector, then we can write V using in what we call now trig form, so in terms of cosine of theta and sine of theta, where again theta is based off of the x-axis. Now you have to keep in mind that all problems don't necessarily base theta off of the x-axis, so you have to be conscious of that.